If the sun is so bright, why is space completely black? It's one of those questions that sounds super simple, right? But in this explainer, we're going to see how the answer takes us right to the absolute edge of astrophysics.
I mean, really think about it for a second. We've got this gigantic, incredibly powerful star right next door, blazing away. So why is everything out there just pitch black? Well, to figure that out, we actually need to peel back a massive cosmic illusion. And it starts right here at home. So let's contrast what we see on Earth with what's actually out there. Look out your window on a clear day and you've got this beautiful bright blue canopy. But for astronauts looking out the window of the space station, it's just a stark, inky void. To understand the darkness of space, we first have to figure out why our sky is blue in the first place. And that brings us to something called Rayleigh scattering. Now, don't let the fancy name intimidate you. Basically, this happens when light bumps into tiny particles that are even smaller than the light waves themselves. When sunlight, which actually contains all the colors of the rainbow, hits our atmosphere, it slams right into tiny nitrogen and oxygen molecules. Think of it like a giant playground. Imagine sunlight is a huge group of kids running into a park full of obstacles. The shorter wavelengths of light, like blue and violet, they're the super energetic little kids, just bouncing wildly off every single obstacle, in this case, the gas molecules. The longer wavelengths, like red and orange, are the older, slower kids who just kind of jog straight through without getting bumped off course. Since our atmosphere scatters those energetic blue kids all over the place, our sky lights up like a glowing blue dome. But here's the catch. Once you leave Earth, the playground completely disappears. Space is a near-perfect vacuum. There's practically zero dust or gas up there to act as an obstacle course. So with nothing to bounce off of, those light particles, or photons, just travel in a straight line, right past you. Unless that light hits something solid, like a moon or your eyeball, you're just going to see total pitch-black darkness. But hang on a second. If space is basically just a totally clear window, that actually creates a massive problem. It's a famous puzzle astronomers call Olber's paradox. Because let's think about the sheer mind-boggling scale of the cosmos for a minute. Scientists estimate there are roughly 200 billion trillion stars in the observable universe. Seriously, that's a 2 with 23 zeros after it. So with that unfathomable number of giant, blazing hot suns out there, shouldn't their combined light completely fill up the vacuum of space?
I mean, for centuries, people just assumed the universe was static and went on forever. But if that were true, every single line of sight from Earth would eventually hit a star. It'd be like standing deep in a massive, endless forest. No matter which way you look, you're eventually going to see a tree trunk. If the universe worked like that, the entire night sky would be as blindingly bright as the surface of the sun. But obviously it isn't. So how exactly do we solve this paradox? Well, it comes down to a couple of mind-blowing cosmic rules. First, light actually has a strict speed limit. And second, the universe itself has a finite age. Because the universe hasn't just been sitting around forever, the light from the most incredibly distant stars simply hasn't had enough time to reach our eyes yet. The night sky is dark because a lot of that starlight is literally still on its way. But wait, it gets even weirder. There is another, arguably much more fascinating reason the sky is dark. It's because our universe is actively and acceleratingly expanding. The actual empty space between stars and galaxies is physically stretching out. And that stretching causes a really cool phenomenon known as cosmological redshift. Imagine a wave of visible light leaving a distant star and heading toward us. As it travels, the very fabric of space is stretching it like a rubber band. Because that star is moving away from us, the light's wavelength just gets longer and longer and longer. Eventually, that starlight gets stretched so far that it completely exits the visible spectrum. It gets pushed right past the red edge of what human eyes can see, turning into invisible infrared radiation. And across vast cosmic distances, it stretches even further into microwaves. And finally, radio waves. So the crazy thing is, the light from all those distant galaxies is actually hitting Earth right now, but it's been stretched into forms of radiation that we are totally blind to. Which brings us to the ultimate twist of this whole explainer, and honestly one of my absolute favorite facts in all of science. Space actually isn't dark at all. Yeah, you heard that right. Our biological vision is just incredibly limited. When you look at the full electromagnetic spectrum, You realize that the visible light our eyes can actually process is just a tiny, microscopic little sliver of the radiation that is actively surging all around us. Like, if you could snap your fingers and suddenly see microwaves, you wouldn't see a dark sky at all. The entire celestial sphere would be completely ablaze with the cosmic microwave background. This is the literal, ancient afterglow of the Big Bang itself. It's this omnipresent energy that fills absolutely every inch of the cosmos, glowing at about 2.7 degrees above absolute zero.
And it totally doesn't stop there. Space is also packed with an extragalactic background of high-energy X-rays blasting out from distant supermassive black holes, plus a cosmic gamma-ray background from exploding supernovas. If we could see the universe as it really is, space would be absolutely blinding. It is a furiously energetic, chaotic, and luminous place.
So the next time you step outside and look up at that pitch-black night sky, don't just see the emptiness. Think about the invisible ocean of light constantly raining down on you. It kind of makes you wonder, doesn't it? Is the universe truly dark, or are we just biologically blind to the dazzling cosmic glow that's been surrounding us all along?